Hi everyone, Ravi this side. Welcome to Engineering Adda. This is the series of design patterns, and in the previous or four videos, you can say we have discussed about the design patterns. What are the different categories of design patterns we have, like creational design pattern, structural, behavioral design pattern, and then we have discussed a couple of creational design patterns like singleton design patterns, factory design patterns, and abstract factory. In this video, we are going to discuss about the one of the creational design pattern, which is builder design pattern. So let's get started for that. And here you can see we have the creational. Inside the creational, we have singleton, factory, abstract, builder, and prototype. In this video, we are going to discuss about the builder design pattern. Okay. Now I will just move you to the builder design pattern, and then we can start discussing that. So here we are on the builder design pattern, and how we can develop or design a builder design pattern. That is what we are going to discuss here. So, first of all, what is builder design pattern? The builder design pattern is a creational design patterns. That means it focus on object creation. That provides a way to construct complex objects step by step. It's like assembling furniture from a manual. So let's say you have parts of furnitures and you have given a manual. Now you want to assemble that furniture to make it complete furniture using the manual. That is how we construct a or we create a object using builder design pattern. Okay, each step adds a part, and in the end you get a fully constructed object. Unlike the factories or the constructor, the builder pattern focus on how objects are built. Okay, so in the case of factory design patterns, we had a separate class which were creating the object for us, right? In the constructor we pass, let's say it is a augmented constructor, then we'll pass all the required parameters inside that argument inside that constructors, and then it will create the object for us. In the builder patterns, it focuses on how objects are built. Okay, giving you a greater control and flexibility. So this is what builder design pattern is. Hope you got the idea of it. It is one of the creational design patterns that provide a way to construct complex objects step by step. If you are a developer, then you might come across the kind of builder classes and how they help us in creating the object, where we try to add whatever parameters we wanted to add to the object. Okay, we can skip some parameters or we can add all of them. So builder design pattern is a creational design patterns that provides a way to construct complex objects step by step. This is what you have to remember. Now going forward, I will explain you how we can develop a builder design pattern and how we can create the object using the builder design patterns, and what are its advantages, why one should use it out, what are its disadvantages, everything we are going to discuss here. Now if I'll go to the next slide. So what is builder design pattern? The builder pattern separates the construction process of complex object from its representation. Okay, this allows customization, clarity, flexibility. So when we say customization, it different configuration of the same type of object can be done. Clarity means it avoids large constructor with many parameters. So let's say you have created one DTO class, let's say house. Okay, and inside that house you have 4 or 5 parameters like foundation. When you are going to construct a house object, that means you need to have parameters like foundation, structure, roof, if you can check if it has a garden or not, it has a garage or not. So there could be so many of parameters or so many of variables you can have inside your class. So it will become very difficult for you to create constructor with the so many of parameters, because you have to remember the order in which you have to pass the parameters in the constructor. So let's say there is a 20 or 30 variables or parameters are there inside your class, then it will be very difficult to create the object with that parameters, and you have to remember the order of them. Okay, so it avoid large constructor with the many parameters. There comes the picture of builder design patterns. And the another scenario is, one is the you have large parameters, then you have to remember the order in which you have to pass it out in the constructor to create the object. The second thing that we need to remember is, let's say you want to avoid couple of variables or parameters to create the object, making them optional. Then again you have to create the different constructor without those parameters which are optional, right? So similar way, if you have 20 or 30 parameters, then you have to create multiple combination of the constructor to create the objects, right? So there the builder design patterns come into the picture. It will avoid those things. Okay. Now the third one is flexibility. Its ability to construct object in multiple steps rather than in one go. So it will provide you the way with the which you can create the object, choosing whatever parameters you want to have or not have. So it will give you the flexibility of it. Okay, imagine building a custom pizza at restaurant. You choose the crust. You can choose the crust like thin, thick, or stuffed, and then you can pick up the sauce, like you can whatever sauce you wanted to have, like tomato, pesto, or BBQ, and you can also add the toppings at top of it, like cheese, pepperoni, or veggies. Okay, so these are the things. This is how you create your custom pizza, and this is how you can create your custom object using the builder design pattern. Okay, at the end the process you get a tailored pizza, and the builder pattern works the same way. It constructs an object step by step based on your priority inputs. Okay, now we'll go to the next slide to discuss about why one should use the builder design pattern. The first thing is, it simplifies the object creation. If the object has many optional parameters or requires a multi-step creation process, the builder pattern simplifies the code. The second is readable and maintainable code. Instead of passing multiple parameter to constructor, you build the object in an intuitive step-by-step manner. The third one is immutability. It allows the constructor of immutable objects by initializing them fully before returning it. So you can make your object immutable as well using this. Now the fourth one is reusability. A single builder can be reused to create different configuration of the same type of objects. Okay. Now the fifth one is prevent constructor overloading. It eliminates the need of multiple constructor with varying parameter list. This is what we discussed, right? So these are the benefit of it, and you should use when there is a large number of parameters are there, then you should use the builder design pattern to create the constructor. So sorry, to create the object. Now how to use the builder pattern? The first thing is, you have to define the product. Let's say you are going to build the house, then you have to define the product. This is the complex object that will be created by the builder. You have to create a class called, let's say, house, which is your product, and you have to define all the parameters inside that class, like let's say foundation, structure, roof, if it has garden or not, if it has garage or not. So those things you have to define, and then use the builder in the then you have to create a builder inner class, and with the help of that you can create the setter inside that, and then try to create the object using those things, those inner classes. We'll discuss how you can do that, and then later on you can use this in the client code. Now I will go to the next slide to discuss key benefit. The first thing is readable object construction. Instead of writing let's say new house and then let's say you are going to provide the house material, like the foundation is of concrete and the roof is of wooden type, and then let's say structure is of wooden type, and then roof is of metal type, and then if you have the let's say garden or not, then let's say garden is true, and if you don't have the garage, then make you false. You construct the object in a natural descriptive manner, but this is not the good approach if there is a large number of parameters you have. So you can use the builder. Okay. Now the second one is extensibility. Adding a new features like let's say swimming pool only requires updating the builder class, not the client code. So if you want to add some new parameters, you can make the changes in the builder class, and you are good to go. The third one is immutable product. Since the object is fully constructed before being exposed, immutability can be ensured. Okay, so you can make sure your object is immutable. Here this give you the power to make your object immutable. Now I will go to the next slide to discuss where does the builder pattern fits perfectly. The first one is complex object with the optional parameters, immutable objects, game development, and file or document generation. Now I will go to the next slide to discuss what one should be careful of while using the builder design pattern. So the first one is overhead for simple object. Let's say you have not many parameters under that class, then you can simply go for the simple object creation. Don't go for the builder. So overhead for the simple object, if the object is not complex or does not have optional parameters, a builder may add unnecessary complexity. The second one is verbose code. The pattern requires additional classes and the methods which can make the code verbose for simple scenarios. So these are the two things you need to keep in mind while you are going to develop the builder design pattern. Okay, so these are the things about the builder design patterns, and what I will do, I will go to the IntelliJ, create one simple application, and then there will try to develop the builder design pattern. And we are going to use the case where we are going to construct the object of house. So just making sure that I'm just going to use that. So let's say it is builder design pattern. Okay, now here archetype I'm going to select is quick start. Make sure you can create any Java project. I'm just creating the Maven project. Okay, I will create it, open it in a new tab, and then wait for a few seconds, and then we can start doing the development of it. Let me close this one. Load the Maven project, and it will take few seconds of your time. Till then I can discuss what we are going to do here. So what we are going to do is we are going to create one class called house. Inside that we are going to keep 5 parameters like foundation, structure, roof, if the house has garden or not, if house has the garage or not. And then we will try to create a private constructor to enforce the use of builder. Okay, we'll try to create one inner class which is builder in this case, and then we'll see how we can use the builder class to create the object of the house. Okay, so I will just open this source, go to the main, and we are good here. Let's say I'm going to create the house class here, and let's say we have private string. We have 4 or 5 parameters like foundation and structure. So those things we can put it here. Any object creation will be fine for you. I'm just giving the example of house here. Okay, so let's say foundation, and let's say private string, structure, roof, let's say it has, I'm just keeping this as a boolean to check if it has a garden or not. Has garden. Okay, garden. And you can also use this one more parameter, like let's say has garage. Okay, so these 5 parameters we keep here for simplicity, but in the real scenario this could be 20 parameters. Okay, now what I'm going to do is I'm going to create one constructor here for this house, so that we can create the object of it. Okay, but I'm making sure that I'm keeping this constructor as a private. Why? So that we can enforce the use of builder. Okay, so let's say private constructor to enforce the use of builder. To enforce the use of builder. Now let's say private house. Okay, and here what we can do, you can set this parameters inside this, but later on we can do that because we need the builder class for this. Okay, so for that, as of now, I'm just going to avoid it out. Now here let me try to generate the this thing, to string. Okay, so just select the to string. Okay, so we have these things ready, we are good. Now I'm just going to create the inner class here. Okay, so why we are going to create the inner class? This would be the inner class, and with the help of this inner class we are going to create the object of the house, and this inner class is the builder class for us. Okay, so let me try to do that. Let's say private, sorry, public static, uh public static. And why we are keeping this static? So that we can use this constructor, private constructor, inside this inner class. Okay, so let's say its name is builder or house builder, anything is fine, house builder. And inside this we are going to have the all the parameters that we have for this house, and with the help of setters method we are going to set one uh, parameters at a time and return the object. We are going to perform the chaining of the object creation here. Okay, so I will show you how you can do that. So first of all, let me try to copy all the above parameters inside the builder class. Okay, and then now we don't have the getter class here. We should not uh, create the getter method here. We should only create the setter method. So let me try to do that. And for the above one, like here for the house, you can create the getters, avoid creating the setters here. And for the inner class or the builder class, you can create the setters method here. So I'm just going to create it out. So go to the generate. Okay, go to the generate and go to the setters, select all of them. Okay, and then click OK, and then it will create the setters for you. Okay, so you can set the roof, foundation, structure, garden, or garage. Okay, now its return type should not be void. It is going to return the builder object. Okay, house builder, you can say. Okay, let me try to refactor this name. Okay, let's say house builder. Okay, we are good now. So it should be this setters method should be returning the house builder here. Okay, and you can see we are getting the error. Why? Because we need to return the object of the house builder. Now let's say you created the object of house builder and you set this roof. Okay, and in that case you should return the object of this house builder with the roof setted. So for that, what you can do, you can simply return this, and this will return the object of house builder with only roof setted. That is why we are returning this here. Similarly, you can return this for the others, and this way you can do is you can create the object with only specific parameters, making the others as a optional. And if you want to add others, you can just do the chaining of object creation, and that will be good to go. Okay, similarly you can do this here and here as well, and here as well. So we are good. Now we'll create one method that will be trying to return the house object, and that method would be public. Okay, so I will create that, just wait. So let's say public house, and this would be the build method, and in the last we are going to call this out. Okay, so this will return return new house, and inside this house we need to pass the house builder object, and that is why we are passing this here. Okay, so return new house, this. Okay, if we'll go to this constructor of the house, we don't have the builder passed here. So what we'll do, we'll try to pass the builder here. So let's say house builder, and now we have to set all the parameters inside this constructor. Okay, so what we'll do, we'll try to have setting for this. So let me do that. This dot foundation equal to builder dot foundation, and that is why we keep all the parameters inside the builder as well. This dot structure is equal to builder dot structure let me try to provide roof first, and equal to builder dot roof. This dot has garden, builder has garden, and then this dot garage equal to builder dot garage, and we are good now. So let me again explain you what we did. We created the object, sorry, we created the class. We created one private constructor of the class. Why? Because we wanted to enforce the use of builder. Then we created two string to print it out. Now we have created the builder class, which would be a inner class. We made it static so that we can access the private constructor of the house, and then inside it out we created the setters method, and we setted the each parameters inside the house builder object one by one. Okay, and then finally we have a build method which will return the house object, and we are passing the builder parameters in the constructor of the house. So this is what we are doing. Now I will create one demo client here. Our client demo anything is fine, and here what we are doing is we are going to have PSVM, and here we are going to see how we can create the object of house. So let's say house equal to new house. Okay, and then just we have to use the builder here, house builder. Okay, and dot, you can set whatever things you want. So let's say I'm going to set the foundation as let's say foundation as concrete. Similarly, you can set the others, like let's say you are going to set the structure as wooden, and then you can also set something like, let's say, roof as metal. Now just going to, either you can have let's say garage or garden, and you can like left others, making the others as optional. So let's say I'm just going to have a garden as a true, and then I'm just not going to use the garage here. So dot build, finally you have to call the build method. Now your object is created, and you don't have to worry about the optional parameters. You don't create the constructor according to the parameters that you are not passing, right? You don't have any constructor here which would ignore the garage. Okay, if you go to the house, you can see only you have one constructor, and all the parameters are inside that. Here you can see, right? You have not created any other constructor which does not have the garage, and still you are able to create the object. That is what I wanted to say. So this is how you can create, and let me try to print out the object here. Let's say house, and we have two string methods, so we'll try to see how it is printing the things. So it is running, just wait for a few seconds. And here you can see the house object is created, and the foundation is of concrete, structure is of wooden, roof is of metal type, and it has a garden, and the garage is optional here. Okay, that is why it is automatically picking up as a false. So this is how you can create it out. Now if you will see, the order of the parameters is also optional. You can pass the parameters in any orders. So let me try to remove this. Let's say we just kept the structure first and the foundation is last. Now still we are able to create the object and it will not give you any error. So now you don't have to remember the order of the parameters, how it is being passed to the constructor. And still you can see it is giving us the object and it is working fine. So this is the builder design pattern, and this is how you can develop a builder design pattern. This is about the video, guys. If you like the video, please hit the like button and please subscribe the channel for more such content. Thanks.